right, so we're going to go over the Unit 4 study guide. So the first thing we had to do was to solve by substitution. So number 1, you would insert what y is equal to, or 3x, into the first equation, or the second equation, instead of y. So you'll have 5x plus 2 times 3x equals 44. So when we solve that, we get x is 4. Now we put that into the first equation and solve. So we have y is 12. So your point is 412. Okay, we're kind of skipping around here. So this is number 3. These tend to confuse people because they don't know what to substitute. You're going to substitute the entire expression on the top for what y equals. So you're going to put 6x minus 5 in for the y in the second equation. So you end up with 6x minus 5 equals negative x plus 9. When you solve that equation, you get x equals 2. Then you're going to plug into either one. It doesn't matter. You're going to plug into the other equation. And I put it into the bottom one, so I have y equals negative 2 plus 9, which is 7. So your point is 2, 7. All right, it looks like I duplicated number 3. Number 2 should be 1, negative 1. 1, negative 1. X is already isolated for you, so let me just write that down quickly so you can see. So number 2 was negative 2x plus 3y equals 11, and then x equals 4y minus 3. So I put that whole thing into the first equation instead of x. When I solved that, I got y equals 1. Then I substituted that into the first one, or the second one, sorry. So I have x equals 4 times negative 1 minus 3, which will give me x equals negative 4 minus 3, and x is negative 7. So I have negative 1, negative 7 as my answer. Number 4, we have y isolated. So I'm going to take what y is equal to and substitute it in for y, being careful because there was a negative sign already there. When we solve for x, we get negative 2. You plug that back in, you have y is 3, so your point will be negative 2, positive 3. When we solve by elimination, for number 1, I just eliminated the y's, already set up nicely for you, so you have x is 5, plugged back into one of those, solved for y and got 2, so my point is 5, 2. The next one, number 2, I just made everything on the top negative so I can add instead of subtract, but you can subtract. So I have negative 9 equals negative 27. You solve and you get 3. I plugged that back into the top one, solved for 4, so my point is 3, 4. Number 3, you had to make some changes here. So I made the top one to have, so I can cancel out the x's. I changed the top one to 12x minus 8 equals 36. Then I eliminated and solved for y. I got negative 6. When I plugged in negative 6 to one of the equations, I used the top one. I also solved for negative 1. So my solution is negative 1, 6. Number 4, I changed the middle term to 8 so that I can eliminate 8y. So I got negative 28x equals negative 28. When I solved, I got x is 1. Plugged that back into the top one, solved, and got y is negative 3. So my points are 1, negative 3. Moving on to graphing, I graphed both of those, and it looks like this should be actually 4 -9 instead of 5, -9. They cross right here. Almost didn't make it. The other ones you had to rearrange, and my intersection was -3, +2. The next couple, you could pick your method. I want to get to mine. You could pick your method. I chose to substitute here. I isolated x and got x equals y plus 11, plugged that in to the second equation where x was, and solved. So I got y is 13. When I plugged, or I'm sorry, y is -3. Sorry. When I plugged that into the other equation, I solved and got 8 for x. So x is 8, y is -3. This one seemed like a good way to eliminate, so I just changed the signs to opposite on the bottom one so I could just add. So I have -x equals -9. Remember, you can't have a negative variable, so I hopped that negative sign over. I got x is 9, plugged that into the top one, then I got y equals -6, so 9, -6 is my answer. All right, the first one here, the school that Danielle goes to is selling tickets to the annual dance competition. On the first day of sales, the school sold 1 adult ticket and 9 child tickets for a total of 117. The school sold 1 adult and 4 child tickets for a total of $57 on the second day. What is the price of each ticket? So I made X the price of an adult ticket, Y the price of a child. Here are my two equations. I eliminated, and here I ended up with $9 and $12. The next one,